Your brain isn't fixed, it's built to grow. Today, you'll learn how to train your mind to learn faster, think clearer, and control your emotions, where we revisit past episodes to bring you the most powerful and practical science-based tools for mental health, physical well-being, and performance. Music playing. My name is Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we're talking about neuroplasticity, which is this amazing ability of our nervous system to change and adapt through experiences. Neuroplasticity is one of the most important features of our biology. It gives each of us the potential to think in new ways, to learn new skills, to move past painful experiences, and to adjust to anything life gives us by improving ourselves. So let's begin. Many people have heard the word neuroplasticity. It means the brain and nervous system's ability to change themselves. All of us were born with a nervous system that was not only able to change, but actually built to change. When we come into the world, our nervous system is ready to learn. The brain and body of a baby are not yet refined. The connections between neurons are rough and not well organized. You can see that in how babies move. They're floppy and uncoordinated. They can't talk and they can't control their actions precisely. Imagine that when you were born, your brain was like a messy web of connections that weren't yet specialized for any single task. Through your life, what you saw, what you heard, the people you met, the languages you learned, the places you lived or didn't live, your brain shaped itself uniquely to your experiences. That's true for much of the brain that deals with the outside world, such as the parts that handle vision, sound, and smell. But some parts of your nervous system were made not to change easily. Those include circuits that control your heartbeat, breathing, and digestion. And that's a good thing, because you want those systems to be stable and reliable. While many brain functions can change, these automatic processes are built to stay the same. As children, teenagers, and young adults, we can learn new things almost effortlessly. We don't need to try as hard to learn. But after about age 25, changing those brain connections becomes more difficult, and we have to use specific methods to make it happen. You can't just decide to rewire your brain. You need to go through certain steps that put your brain in the right state for change. People often talk about growing new neurons through exercise or activities like running. The truth is that after puberty, the human brain adds very few, if any, new neurons. But the good news is that even without adding new neurons, the brain can still change and grow stronger connections. If we set up the right internal chemistry and the right environment around us, our nervous system becomes ready to change, and change becomes likely. As children, our brains naturally want to change. But even adults can access plasticity when they experience certain kinds of sensory challenges or limitations. For example, when someone is blind from birth, the part of their brain that normally handles vision, the visual cortex, starts responding to other senses like touch and hearing. In one study, scientists found that blind people often develop better hearing and touch sensitivity than sighted people. Some even have perfect pitch. This shows that the brain is built to map and represent our personal experience, adjusting to the body and senses we actually use. I once attended a course where a woman told me that my voice made her feel uncomfortable because it reminded her of someone who had hurt her. I couldn't change my voice, but by acknowledging it and talking about it, her reaction softened over time. Eventually, she became comfortable around me, and we even became friends. That experience showed me that recognizing a problem is often the first step in changing it. Awareness is the first step in neuroplasticity. When you decide to change a behavior, learn something new, or respond differently, your brain begins preparing to rewire itself. Simply knowing what you want to change, or even that you want to change something, is what alerts your brain that transformation is possible. This awareness triggers the higher parts of your brain, like the prefrontal cortex, to signal to the rest of the nervous system that something important is happening. A common myth is that every experience changes your brain. People often say things like, your brain will be different after this lecture, but that's not true. After age 25, your brain doesn't change automatically. Change only happens when certain chemicals are released that allow neurons to strengthen or weaken their connections. For adults, attention is what opens the door to change. Only the experiences that you truly focus on create lasting changes in your brain. In the 1,990 seconds, a scientist named Greg Recanzone and his mentor Mike Merzenich at UCSF showed that the adult brain can change when certain conditions are met. They had adults perform very focused sensory tasks, like feeling small bumps on a rotating drum and pressing a lever when they noticed slight changes in spacing. The key was attention. When participants focused carefully on the touch sensation, the map of their fingers in the brain changed. But if their attention was on a sound instead of touch, only the auditory areas changed, not the touch areas. This proved that the adult brain can still be flexible, but only through attention. It's not enough just to do something. You must be mentally engaged with it. Attention tells your brain, this matters, strengthen these connections. So, why does this happen? The reason is chemical. When we pay attention, our brain releases certain chemicals that make learning possible. The first is epinephrine, also known as adrenaline, which increases alertness. The second is acetylcholine, which sharpens focus. And both must be present together for plasticity to occur. A third factor is more acetylcholine released from another part of the brain called the nucleus basalis. When epinephrine and acetylcholine combine in the brain, they open the gateway to change. If you can trigger alertness and focused attention, your brain will change. It has to. That's the foundation of neuroplasticity. So, how can we apply this in daily life? To learn or change, you first need to be alert. That comes from proper sleep, nutrition, or sometimes caffeine. You also need motivation, emotional drive. This can come from excitement, fear, love, or even accountability. Some people commit to goals publicly or set consequences for not following through. Whether it's love, embarrassment, or determination, all these emotions release epinephrine and create the energy needed for learning. Once you're alert, you must focus your attention. Focus is what brings acetylcholine into play. Many people struggle to stay focused, especially with modern distractions like phones and social media. The best way to improve focus is to train it, just like building a muscle. One way is through visual focus. Our mental focus is tightly connected to our visual focus. When you narrow your visual field and concentrate your gaze on a specific point, your brain releases the same chemicals that increase mental focus. When your eyes are relaxed and open wide, you're in a calm state. But when your eyes move slightly inward to focus on something small and specific, your brain becomes more alert and concentrated. Practicing visual focus can strengthen your overall ability to focus. For example, if you need to study or work on a project, try staring at one small area on your screen or page for a minute or two before starting. This helps engage the brain's attention systems. If you're trying to learn through hearing instead of sight, closing your eyes can help. That's why many people naturally close their eyes when they're deeply listening. It blocks out visual distractions and increases focus on sound. While focusing, you'll probably feel some agitation or restlessness that's normal. It's a sign your brain is in the right state for change. Learning happens in cycles, usually about 90 minutes long. Within that time, there's a warm-up phase, a deep focus phase, and a wind-down phase. During the middle part, about 45 to 60 minutes, is when your brain learns best. After a focus session, your brain needs rest to solidify what it learned. Real neuroplasticity happens during sleep. When you sleep deeply, the connections that were activated during learning are strengthened, while others fade away. This is how knowledge becomes long-term memory. Even if you don't get a good night's sleep, you can still boost learning through short periods of deep rest during the day, like naps, or what's called non-sleep deep rest. Studies show that even 20 minutes of quiet rest after studying can greatly increase how much you retain. So to learn effectively, you need cycles of deep focus followed by rest or relaxation. Alternate between attention and recovery. Over time, this balance trains your brain to adapt faster and more efficiently. To sum up, plasticity is available throughout life, but to access it, you must be alert, focused, and rested. Know the time of day when you feel most awake and use it for learning. Don't try to stay focused all day. Most high-performing people work in short, intense sessions followed by breaks. Take walks, relax your mind, and allow periods of unfocused time. That's when your brain consolidates learning. You can train your focus using your eyes or ears, depending on the skill you want to develop. Practice paying attention deliberately, and you'll get better at it. Remember, learning happens during focused effort, but the brain rewires itself during rest and sleep. Thank you for spending your time and attention with me today. If you want to support the Huberman Lab podcast, the best way is to subscribe on YouTube, leave a comment, or rate us on Apple or Spotify. Sharing the podcast with friends and family who might find it useful also helps. And please check out our sponsors. They help us keep producing science-based content. Thank you for your continued interest in science, and as always, thank you for listening.